we have to put that stress X is equal to N mzz over izz multiplied by y. Okay. The next thing that we have to be cautious is when we find the second moment of area I, now we have to include what? We have to include, okay, so we have to include what? N W d cubed over 12 plus by N W multiplied by D y bar minus small y bar squared. Can someone tell me why I put N and width in a bracket and I put D cubed on the outside? Yes. Yeah, well done. Okay. So that when it's a sandwich material, remember, the formula that we are using is based on what? Non-sandwich material. Okay. By the way, this is an approximation. It's not superb, but it's good enough. Okay, this is an approximation. There are different techniques of doing it. For this course, we're going to teach this technique. Okay. So what you see over there, right? If we were to select steel as the reference material. Okay. The original shape, so I'm going to use this. This is our original shape. Okay, we're going, so this is the original. So our original looks like this. So this is our steel. Okay. So this is our steel. This is our aluminum. Okay. Now, if we pick steel as the reference material, remember, when the structure like that, we cannot apply okay, we cannot apply this, okay, we cannot apply this formula. Okay, we cannot apply this formula. Okay. So what we did is we put an N value, and now the steel is the reference material. So when the steel is a reference material, right, what happens to the aluminum? The aluminum have to shrink by what? 1/3. Right? It's going to shrink by 1/3. Okay, but watch this. Okay. So this is still the same. Okay, I'm going to split it up. I'm going to split the steel. So the steel is still the same. Okay. What happened to the aluminum is the aluminum will change in what? So now this is how the aluminum will look like. 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 3. 8 divided by 3. 2.66. 8 divided by 3. 2.6. No, the height did not change. Now we replace the aluminum to become what? Are we clear? So the height did not change. Why the height did not change? If we were to change the height, like what that student was saying, if we were to change the height, the ND will be what? Cube. So it will be N cube. You get what I mean? So we only change the what? The width. Does this make sense? Yes or no? Okay. So i.e. this and this, it can take the same equivalent load. Okay. Just to give you some comedy to laugh. So if this is our aeroplane, right, with some engines, our landing gear is made of what? Steel. Okay. Now, what will happen now if our landing gear is made of aluminum? Any idea? So your airplane will still look the same, right? Your airplane will still look the same, but the landing gear will look this big. Are we clear? Right? The landing gear. Now, in aircraft, it does not work, okay, because of aerodynamics. But a lot of times, the automotive structure are made of steel, can be replaced by what? Aluminum. You just have to be very intelligent in how you squeeze the aluminum into the car. Are we clear? Okay, in airplane, it's impossible. Okay. So just to help you remember what we are trying to do is the what? Is the width that is changing and not the what? And not the depth. Okay. So from here, we know that the stress X of steel will be equal to N of steel multiplied by mz over Izzzy, and the stress X in aluminum is equal to N of aluminum multiplied by mz over Izz multiplied by y. The mz over Izz, okay, are always a what? Are always a constant, okay? So this is for bending. Now, what am I trying to gear you to? We are going to solve this question. GPT or what? Is it? Right? Any answer at all? Because why? I love this problem. That's the next question. Sandwich material and what? What loading are we under? Anyone? Symmetrical or unsymmetrical? Symmetrical. Right? Centric or eccentric. So that's the uniqueness. The student told me okay. Oh. Okay. So before we can solve this problem, we know it's under what? Eccentric loading. Okay. Now, this is just a snapshot of what is going to happen for the next 7 weeks. Okay. We're going to combine different theories together, and you're going to calculate and get useful information. So you realize that under just pure bending theory is not enough. The structure is under what? Axial loading. So the next thing we have to do now, just to quickly remind you, okay, we are going to focus on sandwich material. Or composite material under axial loading. Okay, we are going to do axial loading now. Okay, so for this case, this is our transformation now. This is our X, this is our Y, and this is our rotation about Z. Okay, so we have a material now. Let me put this in a new page, okay? Let me put this in a new page. Pardon me, okay? Ignore me for now. So when I derive, you can see better. Hey. So now we have a structure. This is not the cross-sectional view, okay? And then we have a line over here. So over here, this is our material number 1. Over here, this is your material number 2. You induce a tensile loading. And when it's under tensile loading or before the tensile loading, we have specific distance from here to here. This is known as your what? L0. Did you all derive the formula for sandwich material under axial loading, yes or no? No, or you're just shown the formula? Can't remember? Okay. You did? The previous one, not this one. Okay, so from here, when we stretch it, right, we realize that when we induce a load over here, you will have P1 and P2. Okay, you have P1 and P2. And then I'm going to write note that Px is equal to P1 plus by what? P2. So because of the load, is going to deform. And this new dimension over here this will be known as your L1, and the distance from here to here, this will be known as our delta L. So we are going to make an assumption. Okay, we're going to assume that the strain you know what assume is, right? Making an S out of you and me, right? No, too dry for you. Yeah, assume. Okay, we're going to assume that the strain induced, okay, on both material are the same. Okay, we're going to make the assumption. Okay, and why we make the assumption this is possible? Okay, it's because the strain induced is very small. If the strain induced is large, this assumption is very flawed. Are we clear? Okay. So the strain in material 1 is equal to the strain of material 2, and this is equal to L1 minus L0 over L0, because L0 is your reference material, and this we will get delta L over L0. Okay, so this is our equation number 1 over here. Okay, the next thing that we are going to do, we are going to use this based on what? Based on Hooke's law. Okay, based on Hooke's law, right? We have what? Stress 1 is equal to E1 epsilon 1. And then you will have stress 2. Okay, 2 means material number 2 is equal to E2 epsilon 2. So from here, you come up with epsilon 1 will be equal to stress 1 over E1. Over the other side is epsilon 2 is equal to stress 2 over what? E2. Okay. So we already assume that we have assumed that Px is equal to what? P1 plus by what? P2. Okay. So over here, we have area of 1, and over here, you have area of 2. Okay. So if I were to rewrite the expression over there, right, we can write as Px is equal to stress 1, A1, plus by what? Stress 2, A2. Okay. I see you guys Friday.